It is kind of a funny sound. But then...
Is your computer threatening?
Okay, so remind me, last time we reviewed the abstract keyword. What, right? What does the abstract keyword mean? Why would we use it? I'm going to spit my gum out so I can start chugging coffee. Okay, I know we definitely talked about it this time. What's the abstract word? What does the abstract keyword do, and why would we use it? Make this a quiz. Okay, so when used with a class, the definition of a class, it means you cannot instantiate that class. You cannot create an instance of that class. Why would we ever want to do that? Okay, tell me more. I elaborated. In fact, we actually used an example of it. You gave you the cars and trucks, or both automobile example. So we might have, so it is to support inheritance. That's a true statement. But going even farther than that, you may have a collection of objects, even if it's just two objects, that all have some commonality. But that commonality is something you would never actually create an instance of. Does that make sense? You know, it's too generic, but it's still the core of what makes these other two objects. So given that, we might make this guy an abstract class to put the commonalities in there, and then you create instances of cars or trucks, as our example goes. So that's why the abstract keyword exists. Let's see. Okay, this is not compilers. That's actually a cool class. He's in that class. Isn't that like rough? Yeah, so you guys have that to look forward to. You're doing all right in there, aren't you? Huh? Yeah. Man, a 300 student in 450? You guys don't even know what the abstract keyword is. We're writing a compiler. Good coffee. Decaf? There's like multiple benefits of drinking decaf. One is I don't need all the caffeine because I'm high energy anyways. But the other is that nobody else drinks decaf. So you always have the pot's almost always completely full. They only go to the decaf when they run out of the regular, and that's like the best, like that's the only choice they have. Okay, what was I talking about? Oh, 300. Here we go. Okay, we have our payload object, and then we have a char payload, and we have an int payload. Okay, so what we did is we created this payload object last time, and we made this guy abstract. And inside this guy, we just wrote a single method called getPayload, and we just have the idea is this guy returns a string. It should return the string version of the payload for this object. Okay, and we just have it be a placeholder. If you were seeing this, something bad has happened, and we'll pick up from here in a second. And then we created a char and an int payload. Char payload extends payload, so it is one of those guys, so it inherits that method. If you were seeing this, something bad has happened. Similarly, and then what we did is we overrode that method. We created our own more local version of that method that returned the string version of the payload for a char payload. Similarly, we did the same thing with int payload. Now, I think inside of driver, we go and we add a combination of chars and ints, correct? We implemented inside of our linked list multiple add-end methods. One add-end method takes a char, another add-end method takes an int, correct? What's it called when you have more than one method with the same name with a different number and or type of parameters? Polymorphism. Now one day you're going to tell me we didn't talk about that, right?
No.
I still can't believe we didn't talk about abstract. Is the whole class lying to me? I know at least half of you would lie to me.
Isn't it like against an Amish religion to lie?
I don't think that's actually true. Haven't you seen the Amish Mafia show or the Vanilla Ice Amish show? They should have a show Vanilla Ice Goes Amish versus Amish Mafia. Kind of like Alien versus Predator. What was I talking about? Lost my train of thought. Oh, got it. So polymorphism. We have more than one of these add-in methods. Add front, add-in index. Go into linked list. We'll show that real quick. Let's just go to the add ones. So I actually have 3 add front methods, right? I have an add front that takes in an int, an add front that takes in a char, and then an add front that takes in a payload. Now, why did I make the add front that takes in a payload private? What's the rationale for this setup right here? I have 3 methods highlighted there. Why is that correct object-oriented programming? Or forget about whether it's correct or not. What's the rationale that I use there? Everything I do is correct, so just ask my wife. I got yelled at last night for something that I was going to do that hadn't done. It's my job now since her pneumonia, and I proved that I could actually unload the dishwasher. Now it's my job to unload the dishwasher, and I was going to do it. I was just in the middle of a Hearthstone game, so you had to wait for me to finish the game. So I told, she starts emptying it. I said, "Look, I'm going to do that," and then she just walked away, and I did it. I got a back scratch out of it too. It's an apology. She still owes me a birthday dinner. It's almost a month late now. She was almost dying on my birthday. Somebody can answer this question? Just divulging all this personal information.
Is it because you try to you make it as you try to make it as tight as you can and then loosen the reins?
Okay. Which part of that are you talking about?
Making it private.
Yep. Okay, so I made it private because you want to make it as secure as possible, then loosen the reins as necessary. Okay, so that's why you might make something private. In this specific case, why did I make the first 2 public, one taking an int and one taking a char, and then this one private? Why does that make sense?
Because the ones that are public are the ones that you call to use.
Okay, and this private one, how am I using this private one?
The public methods calling the private method.
Yeah, these guys are only getting called. This guy's only getting called internally. So this goes back to that whole telephone example where we know all the details are inside that telephone, a bunch of weird wires and crap like that, but only the public interfaces are exposed, only the things that we want them to be able to do. So we only want them to be able to add things to our list, to the front of the list, for example, given an integer or a char. We don't want to let them build their own payload. So instead, we take in that integer or char and we build the appropriate type of payload, either a char payload or an int payload. And then we pass it on to our private internal add front method that takes a payload. That make sense? Okay. So if we run this, go back out to driver. We're adding a char here. We're adding an int, a char, an int. Here's an added index where we're adding a char and index 2, and then we're displaying this. So we're proving that we can display all these, right? So there's all our displays. Now, if I go into int payload, and let me just add an S to get payload. Now it's called get payloads. So we basically just broke that override. We're no longer overriding our parents' get payload. We accidentally wrote get payloads. And so now when we run this, for anything that is an int payload, it's going to try to call get payload, and it's not going to find that method in here. So it's going to go up to the parent and use that guy's method. So we're going to have a couple of, if you're seeing this, something bad has happened, blah, blah, blah. Does that make sense? So, question is, as we currently have this written, do we ever intend to have this method called? Never. In fact, that's why we wrote the little stupid method in there. a little stupid statement in there letting us know that something bad has happened. Okay, so what I'm going to do is I'm going to create an interface out of this guy. Now, the difference between classes and interfaces. An interface is a collection of, let's call it class members, that must be implemented by classes implementing this interface. And this implementing is a keyword. You'll see it here in a second. Well, implements is a keyword. Okay, so an interface is our ability to create a list of required methods, for example, that any class that implements this interface must create. And the compiler will yell at us if we don't. All right, so idea here being, well, let me just show it to you. Okay, so we made this guy an interface called payload. Now, interfaces are like classes in that you can have something that is something that implements an interface, something that is one of these interfaces. So we can still refer to them as payloads. Okay, but what we're saying is that this particular payload, anything that implements payload, must write their own get payload method. We're not creating a default one that we never intend to be called. Instead, we're just saying, look, anybody that is going to be one of these guys has to have this method. That make sense? It's kind of like a barcode reader. You know, there's probably 5 or 6 different companies that make barcode readers, but they all probably have to have 3 or 4 different interfaces that work for regardless of what barcode you're scanning. Maybe there's 2 or 3 different styles of barcodes. They all have to have the right way of scanning that kind of barcode. So we'll come back in here, and for int payload and char payload, rather than saying these guys extend payload, we're going to say that these guys implement. As it implements, there we go. This guy implements payload. Oh, well, I left it as abstract. Take an abstract off here. Okay. Oh, we're back in char. Back to int. I saved it all, didn't I?
Yeah, but it's get payload.
Oh! I made the fix. Let me fix it over here first. All right. So I said this guy implements payload, and as something that implements payload, I must implement all the methods that are inside of payload. So one of them is called get payload, and I've already done that, so it's cool over here, right? Now over in int payload though, I've said I implement payload, but it's yelling at me. It's saying, look, there are the type int payload must implement the inherited method get payload. But I've messed up and I didn't quite name it right. So one of the quick fixes is I can say add the unimplemented methods, and it'll go ahead and add them in for me, blank ones. Okay? And then I can go ahead and I can override those methods. So I can take this string here, which is what I want it to have. So similar to generating setters and getters, as soon as I say something implements an interface, I can go ahead and right click on this guy and say, give me all of the things I must write. Does that make sense? So now this guy should work again. So you can almost think of interfaces like classes, but an interface never has an implementation inside of it. You would never actually write any of the methods. You would just prototype them. You're just creating that list of things that you say, you have to write this guy. You have to have him as anything that implements a payload. But we didn't have to go through the stupid waste of time rigmarole. I think, is that a real word or is that just something people say? Is it? No. What's it talking about? Oh, we don't actually have to write any of the stupid methods in here that we know are never going to get called because we're going to force ourselves to remember to implement them later. What's nice about interfaces, it's almost like the police for our code. If we say that a char payload implements payload, it will yell at us if we forget to implement one of the methods that we are required to implement. Does that make sense? So that's kind of a perk of it. That anything that we want to follow the rules of a payload, we must implement. All right, questions about that? So this is us creating our own interface. And let me just quickly go to the Java documentation, and there's a bunch of interfaces already built into the Java documentation. Well, built into Java. The one I'm going to show you real quick is one called Runnable, just because it's related to something that you might want to do at some point. Did they change their... Or did I just click on the wrong thing? Oh my gosh. They changed their site on me. I no longer know how to get to the... There you go. For years, I've been clicking on that for the documentation. Man, I retrained myself quickly. Nope. Nope. Okay, so I'm going to go to java.lang. I'm going to go to java.lang. There we go. And notice here, the very top thing, this is something we've ignored forever. Because when we think about these different things, we look at the classes. That's all we've looked at, right? We also have our errors. These are our exceptions. We've recently written exceptions. So there are exceptions built into the language. We've seen those before. Okay. So interfaces, we have one called Runnable. And the Runnable interface, the reason I chose this one is it's related to threads. So we'll see Runnable. What does Runnable say? Runnable says, you must write this one method, a method that returns nothing called run. Okay? That's all this guy says. You have to write this method. So it might be super fancy or whatever. It sounds, oh, this is difficult. It's an interface called Runnable, and that sounds complex. It's just a set of rules that says you have to write this one method. Now, if we go in, so here's all known implementing classes instead of all known subclasses. So one of our implementing classes is called a thread. So a thread is a class that extends an object, because all classes are objects at some level, right? But it also implements this method called, or this interface called Runnable. So inside here, it's going to have the a method called run. So there's constructors here. Where's the run method? Here's the run method. that it wrote. It wrote some other crap too, but at the very least, it wrote that one run method. Now for threads, and I'll just quickly show you threads. We've talked about threads at least a little bit, right? We would have talked about it in 200 probably. What's a thread? Go ahead.
It stimulates running multi-cores.
Okay, that's not an incorrect answer. Having more than one thing seemingly happen at once. Okay, so a lot of times I refer to them as worker bees. Now, what's cool about threads? Let me just give you a quick example. We'll do this out in driver. So for right now, just comment out the middle of that. Let's say I want to print out all the numbers between 1 and 100, and then I want to print out all the numbers between 1,000 and 2,000. Okay, so I'd write a little for loop, right? For int I is equal to 0. Well, 0 to 100 is what I want to print out, I decided. I plus plus system.out.println I. And then we're going to say for int I is equal to 1,000. I is less than 2,000. I plus plus. Println I. Okay, now you guys don't worry about that. That's from compilers. Okay, so what's the output of this program going to be? I haven't done anything special. It's not rocket science. This is
0 to 99.
0 to 99, then
1,000 to 1,999.
okay, but in order, right?
Yeah.
Okay, so this is going to print out all the numbers between 0 and 99 inclusive, then all the numbers between 1,000 and 1,999 inclusive, in order. You know what? For some stupid reason, I don't want this guy to have to wait for this guy to finish, because this guy is what it's called is he blocks this guy from executing. We do not get to this for loop until this for loop has completed. Does that make sense? But for some stupid reason, I've decided, you know what? I want both of these to happen at the same time. Okay? So I'm going to come over here. I'm going to create a new class. And this is actually going to be really beneficial for you for maybe possibly future solutions. I'm going to show you how to create threads, and you're going to see how easy it is. A lot of people in their head, they just decide, oh, well, threads must be very difficult to write. It's stupid easy. Okay, so we're going to create a class. In fact, every one of you should know how to implement a thread class as of right now without me ever actually showing you. Make it a quiz. Okay, so I'm going to call this guy a loop thread. Okay, now I want my loop thread to actually be a thread. How do I make something be a thread? Extends thread. Okay, so now my loop class has everything that threads have. Okay, but I want my loop class to be a little bit special. What do I want to be special about this guy? You know what? I don't want him to have a run method that does nothing. I want him to have a run method that does something. Does that make sense? Okay. So, now getting back here to our documentation, notice that threads implement Runnable. So so threads implement Runnable. So anything that implements Runnable must implement that run method. So does that mean we have to implement the run method in here? We have a no. How many of you think we have to implement the run method in here? Okay, who thinks we do not have to implement the run method here? Everybody else's hand should be up for good voter turnout. You get like some halvesy hands, so you're willing to bet your grade on it. Okay, so you do not think that we have to implement the run method. Why?
Because the thread already implemented it.
Thread already implements it. Because thread implements Runnable, it had to have implemented the run method. It's probably not the run method we want it to be, but it is already written. And because we are a thread, we got that run method. Again, the run method that we probably don't want it to be, but it is implemented. Okay? So we are not forced to write our own thread method, our own run method. Instead, we can choose to write it if we want our thread to actually be unique. All right? So we're going to go ahead and we're going to write public void run. And we want our run method to loop through a starting number to an ending number. So that means when we build a loop thread, private int start, well here, why don't we call it low, private int high, public loop thread, int low, int high, this dot low is equal to low, this dot high is equal to high. Okay, so creating a loop thread, we're just going to, with the constructor, we're going to read in those two pieces of information. And we'll set our instance variables, our fields, equal to those two pieces of information. So then inside of run, we'll say for int I is equal to low, I is less than high, I plus plus, system.out.println I. And just so we know who is calling this, okay, so we know like which memory address this is coming from, I'm going to print out this concatenated with a space colon concatenated with I. What will this print out? This could be a pop quiz. What is this? Speaking of which, everybody pause. Pause class for a second. I need to show you an extra credit opportunity since I'm thinking about it. Okay, so there's two parts to this extra credit opportunity. So we do lots of pop quizzes in here. My church here in Mequon has a thing called Concordia Sunday. It's coming up on Sunday, March 9th. Beautiful Savior Lutheran Church in Mequon. It's just on it's on Mequon Road. So just go down Port Washington Road, turn right on Mequon Road down by where Panera is. It's like a half a mile down there on the right. So 6 minutes from campus, something like that. I'll give you a free A on a quiz if you show up for the church service from 9 to 10 a.m. Followed by another free A on the quiz, and you can choose to just come to the second part if you want. A free A on the quiz. If you stay for the presentation, it is a presentation where students can ask, here, let me give you the exact topic of the presentation. It's Concordia faculty. It's actually really interesting. It's called Theologians in the Hot Seat. So there's going to be 4 or 5 theology professors and or pastors, and they'll be answering theology questions from the audience. So kind of a cool thing. But most importantly for most of you probably is that it comes with free brunch, free food. Okay, so come to church, get a free A on a quiz, stay for the presentation, get another free A for the quiz, and get free lunch. Okay? That is, yes, you can get it. Is that what you're asking?
I was going to ask how long the whole thing was afterwards, but I can't remember what I had.
Oh, it's probably an hour. That's how long it takes. If you show up and let's just say it's an hour and a half, but you have to leave after 45 minutes or something like that, I'll still give you credit. But don't just show up, eat, and walk out. While I would be impressed. Because that's very likely what I will do. No, my wife will probably make me stay. Actually, my wife's on the committee that's putting on this thing, so I definitely have to stay. But in any case, yeah, I mean, if it's an hour and a half or something like that, and you need to be somewhere and you need to leave a little early, that's fine. But I want to encourage participation. My wife works really hard on this committee to provide this big meal and get all the food and stuff like that. So we like to have a good turnout, as opposed to them putting out this giant spread and then you have 4 Concordia students show up. Then it's like embarrassing. So in any case, I'll give you extra credit if you want to come. I encourage you to come to the church service if you want to see if you're not Lutheran or interested in what a Lutheran church service looks like. Come to that. It's pastor's least decent. Abe goes to my church. I play on my iPad during church.
For the past 3 years.
Longer than that.
Well, it hasn't been that long, has it?
Oh yeah.
When did you start going there?
It's a Beautiful Savior?
Yeah.
Oh yeah, probably 3 years of Beautiful Savior. Yeah, before that I played video games at the previous church.
Did you kick out of that one?
No, I'm kind of a unique individual. Like most pastors kind of get me. The thing is, I pay attention. I way my mind works is just really messed up. So like sometimes I need to distract myself with something else in order to like keep my sanity, or I get like I don't know, it's my autism or something, but I get I don't know, agitated. But when he asks questions or tells his stupid jokes, I laugh at him and stuff. It's not like I'm not paying attention. I'm just giving it the minimum amount of attention it requires.
You can multitask.
Which is weird. Aren't guys supposed to not be able to multitask? I almost have to multitask. Otherwise, I don't know, like life just ticks me off.
He gets bored with life.
Like I was telling my class yesterday, this past weekend I played Hearthstone for 24 hours total over the weekend. But it wasn't because I was playing Hearthstone necessarily. It was because it was this giant golf tournament that I watched. So every single day it was like 12 hours of coverage. Or at least 10 hours of coverage. So I sat on the couch watching golf with my laptop on my right knee, golf here. When it was my turn, play Hearthstone, watch golf. For a day. That was... I even skipped church on Sunday. Did you notice that? I set my wife in my place, in my stead. The semifinal matches were that morning. I even texted Pastor Hillenbrand and said, "Look, I'm not coming, so give Tabby double communion." Was it Communion Sunday? No, the previous time. Yeah, see, I got my fill. I think that's a world Christian. That's a poor Christian worldview. Whatever I just said, don't do that. See, I'm a former Jew, so I can sort of get away with that. Also a true story. I was born Jewish. Isn't that weird? I got the nose. Look at that. Couldn't live with the no bacon thing. It's garbage. That's the best way to convert Jews, too. Go stand outside of a temple with bacon. I tell all my relatives, a lot of them are like Orthodox, but I have some relatives that are Reformed Judaism. What's Reformed Judaism? That's Jews plus bacon. I bet you that was a motivating factor.
How do you cook your bacon?
How do I? Well, it depends what kind of rush I'm in. I actually have a secret way to prepare good bacon in the microwave. In the microwave. Are you ready for the secret? Because usually, if you cook bacon in the microwave, you're destroying it, right? Okay, here's the secret. So I have one of these, microwavable pans that have little ridges in it. It looks like a grilling plate or something like that. Like you're supposed to grill a steak on it or something like that in the microwave. Don't do that. So I lay the bacon all over that. Then I put a whole bunch of paper towels on top of that. And then I put a plate, bottom down on top of that to press everything down so the bacon stays straight. I do really thick cut bacon, cook it for 6 minutes, and then leave it in there for 3 minutes. So everything gets absorbed by the paper towel and stuff like that. It'll be perfect bacon when you bring it out.
How do you cook it if you have more
Actually, anymore, I almost prefer that method. But otherwise, what I'll do is I put it on a broiling pan. You know, like you would use to broil a steak, and I put it into the oven. I broil it for about 5 or 6 minutes. I like it crispy. I don't like that loose, stupid bacon. Bacon should have a strong constitution. You should be able to hold a piece of bacon like this, and it should stick out. Not. I was at Solly's one day, and some guy ordered his bacon. He said, "Oh, I want it loose." I punched him in the face. And it gets even worse when somebody orders their butter burger with no butter. I choke them out and kick them out into the street. It's Port Washington, and it's usually a construction zone, so people are not paying attention to like bodies in the road. What's up?
You ever ordered extra?
I always do. Have any of you ever been to Solly's with me?
I haven't been with you.
Yeah. When I go to Solly's, don't I say don't skimp on the butter or?
It doesn't even matter what he's ordering, even if it doesn't have butter. He would order butter with his coffee if he could.
I don't care if it's cutting 5 years off my life. I'll be happy. Hey, there's something to be said for that. Like my dad's like a health nut. He's how old's my dad? 64. You know, the joke in the Lippman family is the Lippman men die at 58. My dad's father died at 58, but he was a big guy, whatever. My dad's one of 7 brothers. So for years, they kept joking around, I guess partially joking that, oh, the Lippman men die at 58 just because the one guy, the dad, died at 58. My dad's oldest brother, Terry, died on his 58th birthday, which sent ripples through the family. So now everybody became like health nuts. So my dad, I have some picture somewhere, him taking all these like supplements in the morning and stuff like that. I mean, he's already on borrowed time because he's past 58, right? But I mean, he's not dying, but he's not the epitome of health. He's like frail, and he's always got weird issues, and I don't know. I'm all jovial and stuff. I mean, I'd be lucky to make 58. Yeah, I mean, so that's just the beginning of the end. But I'm a pretty happy-go-lucky guy. Plus, even though he's Jewish, I'm convinced Jesus is a bacon fan. So, it's going to be some pretty good suppers and breakfasts and lunch. The rest of you all down here. I think that's Christian worldview stuff. Bacon in heaven, those two just go together like butter and burgers. Okay. What's it talking about?
You were talking about the Concordia.
No, I was talking about bacon in heaven. Oh, then the Concordia. Okay, so everybody got the date for the Concordia thing? I say March 9th, is that what I said? Okay.
And it's right on River Road. You're not really able to see it on Mequon Road.
Yeah, so if you go down Port Road to like where the interstate is, or with Mequon Road, turn right onto Mequon Road, and it's like, I don't know, 2/3 of a mile down the road. You'll see after you pass the Catholic Church on the right at Range Line Road, you'll go through that light. You'll eventually see a white sign on the right side of the road that says Beautiful Savior Lutheran Church, with a little white arrow sign. So just get into the turn lane once you see that sign, and then the church will be the first drive on the left. You'll see it. So good time, free food. Sermons are usually pretty good, and Concordia has strong ties with that church. A lot of the faculty from here, since everybody here has to take some sort of Bible class or theology class, at least 2 or 3 of the professors from theology are members of the church. Nathan Jasper, the chair of theology, is a member of the church. He's a rough guy to have in Bible study. How many of you have ever had Dr. Jasper for a class? Did you like him, hate him? He's a smart guy. Did you know he's kind of famous in the biblical world? He is in charge. You've heard of the Dead Sea Scrolls, right? He's in charge of the Book of Numbers worldwide. The Dead Sea Scrolls. Isn't that interesting? Right here on campus. I see him walking. Well, I was going to say walking his dog, but he's actually walking his grandchild in a stroller out by my country club. He lives here in Mequon. And he spent some time in Asia. His wife is part Asian, and also a member of my church, obviously. But their son, daughter, somebody's baby lives with them, and so I see him walking. He wears these little Asian hats, like the people who do like the fields or whatever, like big sun hats. It's really funny, actually. So those of you who know Dr. Jasper, we're like, he seems like he's really serious. Wouldn't you say that, Evan? Like, doesn't he come off as like super serious? He's like a pretty funny guy, kind of like Locklear. He comes off like all uptight and stuff like that, but he's funny. Don't you think your dad's funny? Yeah, I mean, well, actually, it's probably in the other direction. All right. So, question was, what is this? What does this keyword refer to? Unpause. Not a trick question. Just what is the this keyword? Don't answer any more than that. Just I'm asking you what the this keyword is. Not even in context of this. Just this. What is the this keyword?
First, the most local definition
Of the what?
of the variable.
Okay. Isn't this variable kind of a purpley color? Kind of a super secret special variable? What is this?
Refer to method.
A who?
The method.
What method?
The public void, or would it be the public loop?
What?
It would refer back to them.
Oh, I'm leaving this screen. You guys are confusing yourselves. This. What is this? This is all the context that you need to answer this question. Don't get confused with any of the other code I wrote. What is the this keyword? This is an old review question. Go ahead.
It doesn't go back to the most local definition. It goes back farther.
What? What the heck's going on? What do we need this keyword for? Why does it exist? All right, take out a piece of paper. Get your name on it. Man, I could have asked this question like week 2 of, probably not week 2, week 6 of 250. A half sheet should suffice, so share with your neighbor. Going rate is about 6 cents per piece of paper, so 3 cents for a half sheet. I would start a tab. I guess we're encouraging this Concordia Sunday thing.
I do. Well,
This is called.
my purse is back there.
All right, get your name on it. Tell me what this keyword is in Java or C#. Actually, not C#. Yeah, C#. This keyword in Java and C#. Same. You have 1 minute. Should not take long to explain this.
Do we have to like step on?
Yeah, you got to wager. That YouTube video was an hour of Jeopardy music. Are you a golfer, by the way? Yeah. You should take it up. I just saw you twist. I bet you can hit the ball a mile as flexible as you are. I'm kind of limited on my distance. I could turn through this way. I'm left-handed, so I could turn through this way pretty far, but I can only go so far back this way. And I broke my back. But you're like Gumby. Yeah, the two biggest hitters on tour are both like built like you, tall, slender guys. All right, let's have them.
Oh, sorry.
So can you get him on? No. Can you get the webcam? No.
So out of curiosity, how many of you just committed to Concordia Sunday? Okay, so now does somebody want to tell me what this keyword is? We just like brain farting?
Encouragement to go to church.
I missed my last occupational therapy session.
The this keyword is how a instance of a variable refers to itself within itself.
I think I win.
So if I'm an instance of a variable, if I am inside of the loop thread object, the keyword this means me, myself. This dot low is equal to low. This dot high is equal to high. Ring a bell now? So what happened? Ay, ay, ay. Okay. So, in any case, loop thread is a thread. It's going to keep track of two pieces of information that threads don't keep track of. So we already extended thread to include two ints, a low and a high. When we build a loop thread, we'll pass in the low, we'll pass in the high. We'll set those two instance variables equal to that. Whose instance variables? This is low's variable. That is this guy, the low field owned by this particular instance of loop thread. Set equal to low. This is high's variable equal to high. And then we are overriding the generic run method that thread provides for us with our own version of the run method. And what does this method do? It goes through a loop, starting with I equals low to I is less than high, I plus plus, prints out I each time. But it's also printing out this. And since this refers to an instance, this particular instance of loop thread, this is an object. So when I say this, it's actually calling this is toString method, correct? So what will this boil down to? Did I write a toString method in here? Does a thread have a toString method? Potentially, right? So this is going to either boil down to whatever thread's toString method is, or the crazy memory address. That make sense? All right, so I'm just giving us a little thing so we can see who is printing out the current variable, current value. We should be able to tell by the numbers, because when we create these two guys, one's going to go 0 to 99, the other one's going to go 1,000 to 2,000, or 1,999. Okay, so now I'll go back out to driver. I'm going to get rid of these two loops. Well, before I get rid of them, let's go ahead and create our two threads. So I'm going to create a loop thread, LT1. This guy's going to be a new loop thread, passing at 0 for low and 100 for high. And I'll create another loop thread, LT2. This guy's going to be another loop thread from 1,000 to 2,000. Okay? So there's my two loop threads. Now, rather than calling the run method, threads are this special animal. They are it's a thread of execution which lives inside of a process. So whatever process starts with this program, when we run our program, that program is allotted so much CPU time. What we're doing is we're saying, okay, program, you are now in charge of these two worker bees, these two threads. Schedule them like you'd like. You are sharing your CPU time with these two guys. Okay? And I'll prove that by saying system.out.println here, main thread here, and I'll put some asterisks in the front so we can find it easily. Okay. All right, so got my two threads. So since threads are these special things, we actually have to use the thread start method, which knows how to magically create a thread and call the run method. So we'll say lt1.start, and actually I'm going to move these before this println method to prove my point. And then lt2.start. So I create two threads, two of my specialty threads that just go through. The run method just says loop and print some crap. lt1 start, lt2 start, and then I'm going to print out main thread is here. I'll go ahead and run this. There's my output. Now what we should see in here. Okay, you can start seeing. So even though our two threads started up here, they did not block. So I was still able to print out main thread. Okay, so main thread actually printed out while these guys were still working. Run this again here real quick. Okay, so notice we printed out 1,000, then 0, then 1,001, then 1, 1,002, then 2. And you can see the different threads that were being called. So this is, they did have their own toString method, correct? Okay, so we can see these guys running simultaneously. And there might be some situations in here where the guys get 2 in a row or something like that. There's no guarantee it should alternate. But we can see we have two things, two separate threads running at the same time, correct? The reality is we will probably actually always alternate in this particular case because they're all printing.
The first time you ran it, 1,000 and 1,001 are right next to it.
Okay, got it. But the reason why you probably have a higher likelihood of them alternating in this particular case is because each one's printing to the screen, and printing to the screen is very, very, very expensive. I think we've shown that before, right? So like we create a loop that goes from 1 to a billion and just counts super fast. 1 to a billion and prints, not so fast, right? Because printing, every single time you print something to the screen, you interrupt the CPU. You interrupt the CPU and go and do something. All right, kind of makes sense? So that's kind of a fun thread activity, if you will. And as you can see, there's not too much to them. So if you wanted to create something that did something more interesting than just looping through crap, you can have multiple guys doing their stuff. Okay? Questions about threads at all? All right. So, do we understand the concept of an interface? There's our payload interface. Payload interface says we have to implement this method, just like the runnable interface says you have to implement the run method, which thread does, which we then inherited from thread here and wrote our own run method. So actually the thread example utilizes both an interface and normal inheritance. But threads are not abstract. I don't believe they're abstract. Almost positive they're not. This page just dead. Yeah, public class thread. It's not abstract. So you could create an instance of a generic thread. Here, they even give you an example of your, so you could just take that code and copy it, and that's basically what we just wrote. How to make your own version of a thread. Make sense? Okay. So in any case, that's the scoop with threads. All right. Questions about linked lists in general before we move on to our next data structure. The next two data structures we're going to talk about are actually very simple additions to linked lists. So they're still linked list based, but before we talk about them, let's do we have any questions about linked lists in general? Okay, so again, linked lists, very memory efficient, not so performance based. We can increase the performance of them by adding a tail. We could also increase the performance of them by making it a doubly linked list. That is, not only does every node have a next node, it also has a previous node. So you can walk forwards and backwards. Okay? We can leave that as an exercise for the reader. Not a huge change there, right? Adding and removing nodes becomes a little bit more of a headache because now you have an extra pointer to hook up. But, you know, draw your pictures, it's the same deal, right? Okay. So, what am I doing here? Let's talk about a stack. So our next data structure is a data structure called a stack. Stacks are actually used very, very often. What is recursion? Go ahead.
Calling the method that you're in inside the method.
Okay. When a method calls itself. Recursion is when a method calls itself. Good example of recursion is factorial. That is, 4 factorial is equal to 4 times 3 factorial, which is equal to 3 times 2 factorial, which is equal to 2 times 1 factorial, which is equal to 1.
I think your math's a little off.
By who?
4 factorial does not equal 1.
No, I'm doing the whole the train. This will make more sense this way. What is 4 factorial? 4 factorial is actually 4 times 3 factorial. What is 3 factorial? It's actually 3 times 2 factorial. What is 2 factorial? 2 factorial is 2 times 1 factorial. What is 1 factorial? It's 1. Then you walk back up. So now we can solve the problem of 1 factorial. It's 1. Now we can solve the problem of 2 factorial. It's 2. Now we can solve the problem of 3 factorial. It's 6. Now we can solve the problem of 4 factorial. It's 24. Does that make sense? We had to keep putting, well, before I talk about the stack aspect of it, this is the recursive aspect of it. So if I came in here to driver and I just wrote a quick method, static int factorial, takes in an int n, we'll ask the question if n is equal to 1, I'll do the curly braces, return 1, else return n times driver dot factorial of n minus 1. So this is a recursive call. when a method calls itself from within itself. Okay? And often, to show the real power of recursion, this is written without the curly braces. So you might do something like, you can either say return 1 or return n. So that's the same method. So you can write the whole thing in 2 lines. So one of the benefits of recursion when a method calls itself, one of the benefits, and apparently I picked the weird 2-column slide, one of the benefits is elegant and small footprint solutions. So your recursive solutions to problems tend to be small in size. You're accomplishing a lot through the power of recursion. Costs. Very memory inefficient. So far our trade-off seems to be the trade-off between performance and memory efficiency, right? Things that are less memory efficient tend to be higher in performance. Things that are more memory efficient tend to be worse, slower in performance. Okay, so that's the concept of recursion. Now, why does recursion cost so much? Well, if 4 factorial is equal to 4 times 3 factorial, if that's true, then what we need to do is when we call factorial of 4, and from there, we decide we're going to say 4 times 3 factorial, the factorial of 3. Okay? We cannot solve this problem until we have an answer from this problem. So we need to put the current version of factorial of 4 on hold. We need to store it somewhere. And that's done on top of a stack. Okay, so your computer has a memory stack. Java, being a virtual machine, has its own stack within it. So for instance, if we let me just create an infinite loop. So let's say that I forget to say n minus 1, and I tried to calculate the factorial of 4. Is 4 equal to 1? Nope. Return 4 times factorial of 4. This would be an infinite loop, right? It's just going to keep calling it forever. But the issue here is that every single time it makes a call, it has to put the current version of the method on hold and store it somewhere. So what it does is it packages it up into like a method container to remember the current state of all the variables and all that stuff, and it shoves that onto the stack. And to show this, I'll say driver.factorial of 4, and you'll see that a stack indeed exists. So I'll go ahead and run this, and it's going to sit here, and it's going to scream for a second, and then eventually, let's give it a moment. We get a stack overflow exception. We eventually ran out of stack space. Okay? That protected us from running out of memory in our computer. So think about this if we were doing it in an older language like C++. That does not protect us from that. We can literally crash our computer because we use up all of real memory. Does that make sense? We're not protected by that virtual machine thing. Okay, so we will come back on Thursday and talk about implementing stacks of our own. Okay? I will see everybody on Thursday. Don't forget, faculty, student, staff, Bible study, Lakeshore Room, noon if you want. Comes with free lunch. Go to the cafeteria, tell them you're here for the Bible study, sign in, grab a tray, take your food over to the Lakeshore Room. It's a big party, God and grub.
And work.